AP Chemisters, this is Mrs. Vanderwally. You should have received a text from me not too long ago about finishing the problems in your notes and then check your answers on this video. So if you haven't done so already, please go ahead and work on problem number, what was it, 50? No, 49, because we stopped off here at problem number 48. So go ahead, do number 49. It's got to read it very carefully in order to figure out what goes where. So try to go ahead and make sense of what's going on here. By the way, here's the equation that you should have written down. Let me give you a hint. What you are solving for is not that right here, the delta H of the reaction. That delta H of the reaction was given to you. That's what this number represents. And one thing you really have to be careful of in doing these problems is reading the problem carefully. What is it that you're given and what are you solving for? So you are given the heat of the reaction, how much energy was released during this combustion of ethane gas. That is your delta H reaction. You are actually solving for the enthalpy of formation of ethane. You are solving for example, one of these numbers in here. So go ahead and if you haven't done this already, pause this, work on the problem, and then see how you did. Well, hopefully you got that. I would really get into the habit of writing out the formula every time. That delta H of the reaction is delta H of the products minus delta H of the reactants. So these are the heats of the formation of the products minus reactants. So if you notice, I just explained why I put this number right here. That's how much energy this combustion reaction has released. Here are your products. So you have 2 moles of carbon dioxide, and here's the heat of formation of carbon dioxide. Here's your 2 moles of your water vapor and its value for the water vapor. So a 280 something 0.8, I can't read my own writing, I think it's 286.8. Minus, this can be this number right here. Here's your heat of your products. 1 mole of your ethene plus 3 moles of oxygen. But wait a minute, 3 times 0 is still 0. So that's your oxygen value plus 0. You are solving for X. Watch your algebra skills. So what I did is that I carried through this negative 114.11. I combined these terms. I got negative 1358.6. Don't forget, watch your signs carefully. Minus 1x, 1 mole of X. So if you solve for X, I would add 1358.6 to both sides and then divide by negative 1 to get X equals positive 52.5 kilojoules per mole. Why did I stick this 1 mole here? Because I end up dividing the kilojoules by, do you see where my pointer is? That 1 mole. And that's the proper unit of a heat of formation. So why don't you go ahead now and work on problem number 50. It is very straightforward. You are solving for the heat of this reaction. So go ahead, write down your formula, products minus reactants, set it up, and pause this in the meantime while I magically show you what your answer is. Ta-da! So again, heats of the sum of the heat, formation of products minus the sum of the formation of the reactants. You'll see I have these numbers here. So this 2 goes to iron. I don't know why I reversed them, but the iron is 0. 1 mole of the aluminum oxide. Those are your heats to your products. And minus, here's your heat of formation of your reactants. So the aluminum is 0. Your iron 3 oxide is negative 826. Notice all your moles cancels out. So negative 1676. Why is this a plus 826? Well, a minus times a negative is a positive 826. So you get a total heat of this reaction is negative 850 kilojoules. All right, go ahead and let's look at problem number 51. Okay, my advice for this problem is don't be afraid of all the verbiage, all right? The heart of the problem is actually right here. Use the standard enthalpies of formation to calculate the combustion of octane and then determine, all right, that's the second part of the problem, how many kilograms of octane would be necessary to produce this. You never use 100,000 people. You're going to use this in the very last step. So what do you need to do first? Well, I think you need to write down your equation for the combustion of octane. So if you haven't done so already, why don't you do that? All right, here it is. So I left everything in nice whole numbers, but notice by leaving them in whole numbers, you need a 2 as your coefficient of octane. It's not a problem. You're allowed to do that, but just come back and make sure you know there's a 2 in front of the octane. Excuse me. So go ahead and now solve your heat of reaction where you're using your products minus the reactants, and let's see how you do there. All right, so again, notice I'm not being lazy. I'm writing down my equation. So it's the sum of the heats of formation of products minus the sum of the heats of the reactants. I have to say this, I'm not being lazy. I left out the moles in my units in this particular problem because I could not fit it in. I tried, I'd erase it. So notice that this is 16 moles of carbon dioxide times negative 393.5 kilojoules per mole. This is 18 moles of water times negative 242 kilojoules per mole. If I had written it in, I never would have fit it in. So I'm not lazy, I just couldn't do it. All right, so minus the heats of the product, or excuse me, heats of the formation of your reactants. Here's your 2 moles of octane. I had to use the book for this number. It was on page 279. If you couldn't find it, so it's negative 250.1 kilojoules per mole. And then again, plus 0. Where did 0 come from? It's your 25 moles of oxygen times 0, because that is the standard form of oxygen, so it's a 0. So I got negative 10,151.8 kilojoules. And again, note, this is for 2 moles of octane. Make sure you always go back and look. So the next part of the question, we have to answer the questions. Using that, all right, determine, there's a typo, how many kilograms of octane? So you're looking for question mark kilograms. All right, well, what are you given? This here is your given. So if you write this down next, okay, make sure you always write down your units and factor labeling. Finish the problem. Go ahead and pause this while you finish if you haven't done so already. Okay, there's my answer. So I used this as a conversion. So I put kilojoules on the bottom, moles on top, moles on the bottom, grams on top, grams on the bottom, kilograms on top, and I got 2.9 times 10 to the 6 kilograms. All right, problem number 52. If you haven't done so already, go ahead and do it. You don't need me to explain anything. It's very, very straightforward. Go ahead and solve it. So pause this if you haven't figured it out already, and when you come back, I'll have the answers. All right, ta-da! Again, I wrote down my formulas. I was able to fill in all my units again. Phew. So my 2 moles of the iron 3 oxide, here's this number again. 4 moles of iron, well, it's 0, isn't it? It's in the standard state. 3 moles of oxygen gas, well, that's 0, it's in its standard state. So really, the heat of formation of my reactants is all zeros. So you're only worried about this. So I get negative 1652 kilojoules of energy for every 4 moles of iron. To answer the question, how many kilojoules? Well, you start off with 15 grams, grams on the bottom, moles on the top, moles on the bottom, kilojoules on top, and I got negative, really with sig figs, negative 111 kilojoules. All right, so that's everything. I'm going to be assigning your homework shortly. That's going to be book work. It's going to be due on Wednesday. Now, if you are absent, there's not a whole lot I can do about that. You may want to check in later and see if your homework is correct. You will have a quest on Thursday. If you are absent, make sure you know if your homework is correct or not. I'm going to be giving you the odds. So if you do not get the answers right on the odds, then you need to come in and during office hours. So you can come in Tuesday morning, or Wednesday morning, Wednesday afternoon, or Thursday morning. Make sure that your homework is correct. Stay tuned. I'm going to be talking in the next video about our lab tomorrow. Bye-bye.